extremely quickly. As statisticians, should we be concerned in all senses of the word? In early February, the business columnist of The Economist newspaper wrote, "If you ask something of ChatGPT, the responses you get back are almost instantaneous, utterly certain, and often wrong." They added, "It's a bit like talking to an economist." Later that month, Rory Sutherland in the Spectator newspaper wrote, "There will be hundreds of social and professional occasions where it'll be necessary to prove that we ourselves wrote the words being sent. And the only way to do this will be to use words that ChatGPT won't. As it explains, I adhere to ethical and legal standards, and I will not generate content that is harmful, discriminatory, or offensive in nature or otherwise unethical." So he reaches the obvious conclusion about how to prove that you wrote something yourself. Well, perhaps this is true, perhaps not. We're fortunate today to have Hannah Kirk to speak to us. Hannah's a PhD student at Oxford in social data science. Her research focuses on the scalability of human and model-in-the-loop learning, which I hope she may explain, and the role that dataset generation, curation, and labeling plays for aligning values in large-scale language models. Please note that the RSS is recording this event. It'll be put onto our YouTube collection together with the slides afterwards. If you could all make sure your cameras are off, please. Make sure you're muted. And if you have comments or questions, please use the chat function on your screen, and we'll come to those after Hannah has finished. Hannah, now over to you.
Thank you so much, Phil. Can everyone hear me okay? Maybe Phil can just give me a thumbs up. I think we're probably good. So lovely to meet you all. I'm going to be talking today a little bit about ChatGPT, but very much unpicking kind of what's underneath the hype that we've seen in the past couple months. I was just explaining to Phil and Kate that I've been doing my PhD on language models for a couple of years now. And, you know, for 2.5 years, no one really cared about language models. And now they're everywhere. They're all over Twitter. They're in lots of magazines, lots of newspapers. So today I'm going to be unpicking a little bit of what a large language model is, firstly, and how really statistics is at the core of these models. So if any of you are familiar with statistics, then a lot of this shouldn't be new. And we shouldn't think of these models necessarily as more complicated than the underlying statistics that drive their outputs. Second part of the talk, of interest to any statisticians in the room, I'm going to be talking about whether ChatGPT will steal your jobs or ruin your students in your lecturing schedules. Bit of a disclaimer, you're probably going to be okay. I think there are a lot of weaknesses with ChatGPT that we do need to bear in mind, even if we do incorporate it into our workflows. So with that said, I'm going to start to make sure we're on the same page with a definition. So a large language model, commonly referred to as an LLM, which is a bit of a mouthful, is a large neural network, and this means it has many parameters. So for example, GPT-3, which ChatGPT is built off, has 175 billion parameters, and reports have suggested that GPT-4, kind of the latest iteration in this GPT family, may have up to 1 trillion parameters. This has not been confirmed, but definitely these models are very large in the terms of trainable parameters that they have. And a neural network, for those who aren't familiar, essentially can process multidimensional information into a single unit. And it consists of these things called neurons, which are inspired by brain functions, which basically takes an input X and maps it to a function f of X. A large language model is also large in the sense that it's trained on a very large corpus of text, so many hundreds of gigabytes, and we maybe have seen reports that GPT-4 is trained on up to a terabyte of data. So this is an enormous amount of text data that the model is learning from. And the point of a language model is to estimate probability distributions over sequences of words. So these are the core components of what a language model is. It's a large neural network trained on a large corpus to estimate these probability distributions. And just to get it straight at the start, ChatGPT itself is not technically a large language model. It's an interface for accessing a large language model. And that large language model is called GPT 3.5. I'll go into this in a little bit more detail later to kind of explain what components make up ChatGPT. So as I mentioned in today's talk, we're going to cover three things. Firstly, how an LLM actually works, so a bit of background on the statistics that lie at the heart of LLMs. Then we'll talk about how maybe LLMs can be used in statistical applications. And finally, I'll offer a couple cautionary tales for what you should bear in mind if you are going to use LLMs and interact with them on a frequent basis. So it's worth saying before I start that the past couple months have been really crazy in the field of AI, both in academia and in industry. So I think if anything screams kind of AI arms race, it's this month-long period from February to March. So you can see multiple industry players. We've got OpenAI, Meta, Spotify, Microsoft, Google, and Anthropic are releasing lots of models in very short succession of one another. And all of these are pretty large kind of developments in the field, and they're very concentrated in a short time period. We also have a couple contributions from academia. So you can see here, Stanford released a big model on March 13th, and also some more open source communities like Midjourney. So this is just to show you that things are moving really, really fast. And so it's very important to bear in mind this pace of progress when we think about the integration of these models into society. So the first section I'm going to talk about is statistics in large language models. So to start with some basics, let's talk about sequence probabilities. So here's a very elementary probability question. What's the probability of picking a purple ball from the bag? Now, I won't test you on this one because I think most people probably can answer this if they've completed high school. So we count the number of balls in the bag, we count how many of them are purple, and we simplify the fraction. Now imagine we have a text corpus. Now, in a text corpus, it's impossible to capture all written text ever. So we just have a subset of collectible ones. This would be a bit like using the bag of balls to estimate all colored balls in the UK, for example. And that's not a very good idea. But as the bag gets much bigger, we get a better estimate. So this is kind of the text corpus that underlies language models. And here's just a toy example of that. So we can look at this text corpus and we can think about what's the probability of a sentence in all written English text based on what we have in our corpus. Well, if there's a sentence in our corpus, for example, the ball is purple, we can do the same thing that we did with the bag. We can count the number of times that sentence appears and divide it by the total size of our corpus. Now consider these two slightly different sentences. So in the first one, someone has clearly made just a typo on the word but the grammar and the flow of the sentence is the same. So it still says the ball is purple, albeit with a typo. The second sentence is much more unusual in terms of linguistic norms and grammatical structure in English because it reads as ball the purple is, also with a spelling mistake. The problem with this is that in this toy example, neither of these sentences occur in our corpus, but one is more likely. So this is a bit of a problem because we want to be able to know kind of which ones are more likely, even if they're unusual and don't appear in their exact form in our training data set. So what can we do? Well, we can break down a sentence into conditional probabilities. So consider the probability of this sentence, the ball is round. We can break that down into the probability of the word the conditional probability of the word ball, given we already have the in the first position, and so on until we get to the end of the sentence. And this idea really underpins one of the fundamental equations of language modeling. So in general terms, the probability of a sequence of words can be decomposed into these conditional probabilities via the chain rule. And so we can summarize this historical sequences of words and the probability of a given word, given the past history of words in our text, based on this product of probabilities. And this thing, the product, is exactly what we want to estimate with a language model trained on a corpus of text. So what is that text in a model like ChatGPT? Well, there's a number of different GPT models kind of that have been released over the past couple years. We can see in GPT-1, it was trained on about 5 gigabytes of books, both fictional books, non-fictional books, across a number of genres. When we move then into the second iteration, GPT-2, it was now trained on about 40 gigabytes of Reddit links, so Reddit posts, comments, etc. Finally, GPT-3 was trained on much, much more data. So we're starting to approach a terabyte of data here, and over more sources as well. So it had a large amount of English Wikipedia, also some academic journals, and Common Crawl, which is a URL-based kind of snapshot of the internet, which is taken at different time points. It's unconfirmed how much data GPT-4 had, but possibly reports have suggested that it's got an even more diverse and larger data set, up to maybe a petabyte of data. So these are really big data sets that we're now training these large language models on. So I'm just going to give a little primer on how we then take this learned model of the world, of how language is used in the world, and use it to generate text. It's worth saying before I begin, I'm going to explain this simple example of that we just give the language model one word and ask it to output the next words. You're probably familiar talking to ChatGPT in terms of prompts, and something to bear in mind is that when you input a prompt, say like a question, what day is it today? What's the weather like in Glasgow? You're actually just starting the sentence, and then ChatGPT is conditioning what it's following afterwards, given on what you inputted to the model. We're going to simplify things and just imagine that there was a setup with ChatGPT where you could just put in one word and ask it to complete the sentences. So let's start with just the word the. Well, the language model that we've trained outputs a distribution of what candidates could go in this gap. So this is just a toy example, but some might be much more likely. Let's say the cat is very likely, the banana is very likely. Somewhere in that distribution, we have the ball, and right down at the bottom, we have very rare words. So ragamuffin is a breed of cat, and that maybe occurs very infrequently in our corpus. So it's got a very low probability of occurring in this gap. So what we do now is we sample from this distribution of the model. And there's a number of different ways you can do this. You could always just take the top most likely word, but that doesn't really give you much diversity. So there's a couple other ways which sampling is done from this probability distribution. The first is that we can control this parameter called temperature. And what temperature does is it kind of reallocates or modifies the confidence over these probability outputs, over this probability distribution. And if we have higher temperature, we kind of boost the unusual words higher up the distribution so that they're more likely to get selected in that gap. We can also do something called top K sampling. What this does is we choose a fixed K, and K could be 10 or 15 or 1,000, and then we sample from that batch. So the higher the K, the more words we can choose from. If K in this example was 2, we would only ever choose from cat and banana, but if we increased it to say 100, maybe ball would then come into our candidate set. A fixed K is not always a good idea because we might actually have a very peaky probability distribution where the first couple of words make up a lot of the probability mass and much more likely than the words that come afterwards. So something else you can do is called nucleus sampling or top P sampling, where we first define what percentage of the probability mass we want to sample from, and then look how many words get us to that mass cutoff. And this allows the choice set to be dynamic based on context. So let's say we choose one of these sampling methods and our chosen candidate word is ball. We now have the string, the ball gap. So we now use that to generate the conditional probability distribution of what goes in that gap, given we already have the and ball. And so here there's a number of different candidates, maybe is and was are very likely, flew is probably less likely. So once again, we sample one of those words and we repeat these steps. So now we have a gap after the ball is, rolling around, a pretty likely, maybe purple's a little bit lower down the distribution, and supercalifragilisticexpialidocious is very, very rare. So that's unlikely to get picked in that candidate position. And once again, we pick one of the words, and this is how generation works. It kind of builds up the sequence based on the history and these probability distributions. So with those kind of priors established, I'll walk you through a little overview of the steps that contribute to what ChatGPT actually is, and hopefully during this overview, tackle some of the misconceptions about ChatGPT. So the first thing we do is we collect the corpus, which I explained in the previous slide can come from a variety of resources: book corpus, Wikipedia, Reddit, journals, or the Common Crawl. And this is a very large data set, remember? We then pre-process the corpus. So remember that we want to split it down into subtokens, because this makes it easier to process the sequences without having lots of sequences that our model hasn't seen before. So if we split it down into little subfragments, our model is much more likely to have seen that word before and also to have a probability estimate for the occurrence of that word. So let's think about this string. Statistics is the best subject. I love it. So obviously the first part is fairly standard, but we've got this kind of slang spelling of love. And what we want to do now is tokenize this string. It's called tokenization when we split one string into substrings or tokens. One thing we could do is just split on the white space. Note that this doesn't really work for some languages like Mandarin or Japanese, but in English we could split on the white space. But once again, this is a bit of an issue because our model might not have seen this word before, love with lots of O's, and so it won't be able to encode a probability for that word in that position. So what we could do instead is break down by characters, but that's not very good for learning context and not very efficient. So what a model like ChatGPT actually relies on, an interface like ChatGPT relies on, is this byte pair encoding, where we break down the words sometimes into full word tokens and sometimes into subword tokens. So you can see here that we now have I, L, OOV, of and it. So it breaks it down into things that the model is more likely to have seen, and this overcomes the unseen vocabulary problem, the difference between training and inference time. So once we've pre-processed the corpus, we need some sort of algorithm or architecture to process it. And this diagram is a little bit complex and small, but I think the key takeaway is that the GPT model is based on the transformer architecture, which was introduced by Vaswini in 2017. And essentially what the transformer architecture is very famous for is using this self-attention mechanism to process sequences of input data. And the self-attention mechanism just allows the model to focus on the most relevant parts of the input data, and this helps it to better understand the context of the text. It also has a positional encoder, so we can learn different things about the words depending on where they appear. There's some great resources online for understanding the transformer architecture, both kind of more simple ones and more technical ones. So I'd really advise you to go and look at that if you want to know more about the specific language model architecture. So once we have the architecture and we have our process corpus, we can move to the pre-training stage. And pre-training is this period of unsupervised learning for the model, where we don't give it human labeled data, we just give it the raw text. And the way that we process that raw text into a training task is using this next token prediction. So there's a lovely animated diagram here, which I did not make. Jay made it, and he's got a lot of great visualizations on language model training. But what we can see is the way that this pre-training task works is we take a sentence, we put it into the model, and what we ask the model to do is to predict what word comes next in the sequence. So you can see here, the model predicts that it's exterminates, and actually we know that in the ground truth sentence, what really appeared in the training data, that the sentence was a robot must obey. So we then communicate to the model that it's made an error, and we propagate this loss back through the model. I can talk some more about the loss in the questions if people are interested. It's based on a cross-entropy loss. So we think about the distribution of the output predictions and probabilities from GPT-3, and we compare that to what we observe in the training corpus. And we essentially get the model to update what it knows about language based on this loss term, so that the next time we feed a similar sentence through the model, it puts a higher weight on obey and a lower weight on exterminate. So these 4 steps together are what make the GPT-3 model. That was released, I think, 2 years ago now, and is still available online for you to use in its base form. This is a base language model that hasn't had any additional tweaks on top of it. So what are the other tweaks that get us to ChatGPT? Well, first we have some instruction tuning. Now, instruction tuning is a way to make the model more kind of flexible to understanding how we would interact with it normally, which is through natural language and making requests or task completions to the model. So once we have a pre-trained model, it's not very good at interpreting requests because it's only been trained on this objective of next word prediction. Once we have instruction fine-tuning, the model just gets a lot more usable. And this, with the 5th step, is Instruct GPT-3, which was a different model which was released last year, I think. And then we take the Instruct GPT model and we do what's called reinforcement learning from human feedback, RLHF. And the key idea of this, and it does really change model behaviors, is to bring a human into the loop and have them evaluate model outputs and rank them. So we can see here from this figure from OpenAI that we get a language model to generate 4 candidate answers to a particular prompt. We get a human labeler to rate these examples from best to worst. And then we train a separate model to predict how a given output is likely to be rated across different humans. And then we can use that reward model to feed back into the language model so that it starts to learn how to generate output sequences that are more likely to be preferred by humans. Once again, I'm doing quite a lot of my PhD research on this particular step of the ChatGPT journey. So happy to talk about it more in the Q&A as well. I'm not entirely sure whether ChatGPT also had a period of red teaming. So red teaming is used to describe kind of a safety mechanism that OpenAI use, where they bring in domain experts or researchers, essentially to interrogate the model over a period of a couple of weeks pre-public deployment. And this is essentially to find cracks in the system, to find biases or harms that the model still encodes, which can then be patched before the model is publicly released. I did some red teaming for GPT-4 and DALL-E with OpenAI. So if you have any questions about that, we can also discuss it in the Q&A. So these 2 steps move us from Instruct GPT to GPT 3.5, which I think is also called GPT Turbo. And then finally, it is the interface on top of GPT 3.5, which is technically ChatGPT. So that's just one thing to bear in mind when you're thinking about these models, is that ChatGPT is the interface and it's based on kind of all of these different histories of GPT models. So just to describe, this is a very kind of distributed and multi-step environment. And there's a couple of analogies which I like to bear in mind when I think about language models. So this is one from Jan LeCun. He describes this kind of stepwise process as a cake. The unsupervised and pre-training part is the main part of the cake. We add a bit of icing with the instruction fine-tuning so that the model is more usable and can predict our intent better. And then finally, the reinforcement learning from human feedback is a little cherry on top. I don't think this analogy is perfect because obviously when you eat a cake, you get all of the different layers separated. And in reality, when we're interacting with a language model that's been trained under these steps, we're really only interacting with the cherry. So this is a slightly better, but albeit a bit more gross analogy. So a Shoggoth is a fictional monster from Greek mythology, I think, and they're kind of amorphous creatures. They shift shape and form. And the reason that I like this analogy, even if it is a bit disturbing, is because this is really how I like to think of a language model. We have this big kind of shape-shifting, difficult to understand beast that's the unsupervised learning, and it's very hard to interrogate what's going on there. We add kind of a bit more human interactability with the supervised fine-tuning over instruction data sets. then RLHF kind of tweaks that even more, and we get this little happy yellow guy, which is what you actually interact with. But that kind of sits on top of all of this different part of the model, which is very, very shape-shifting, very hard to understand. And so that's something to bear in mind when we interact with language models, that ChatGPT has been very conditioned into quite a narrow space, but underneath it, the models that are underneath it are quite unpredictable. So with all of that background established, I'm going to talk about a couple of examples of how I see LLMs and how they could be used in statistical applications. So I'm going to talk about these two papers first, which I think really well illustrate how models like GPT-3, which have been trained on these enormous corpora, can be used to estimate public opinion or for large-scale opinion mining. So this first Stanford paper came out pretty recently and is quite similar to some of the work I'm doing at the moment. And they suggest that we can essentially compare what worldview a language model embodies with real human respondents to large-scale surveys. So we can embed kind of a persona in a model, let's say this Democrat persona. We can ask it a question about, this one's about gun control. We can see what it would answer in that setting and compare that to how humans answered that setting in a population level survey. So this is something that's really interesting to think about. Who do language models represent, and can they play these different societal personas to some degree of fidelity? So the next paper takes this idea and actually proposes we can use language models in place of sampling human populations. Take this with a grain of salt. I think it's a little bit risky to actually say that we can use a language model as a base for a survey instead of recruiting human participants, but it's an interesting idea. So what they do here is they condition the model, GPT-3, with a backstory that kind of describes a certain human profile. And then they say that we can use the model to predict voting behavior. And they show that GPT-3 can actually quite successfully predict voting behavior, albeit for the American electorate in 2020. So it hasn't been confirmed how these results transfer to more diverse populations. But an interesting idea that because ChatGPT has seen this large amount of text corpora, can we use it to make estimates about population opinions? A couple of other kind of toy examples of how I see LLMs being used in statistics, especially in kind of an educational setting. One thing that they could be used for is communicating statistical results. So I did this little toy regression just as an example, and it's a regression of the number of pats that a given cat received based on a number of factors about that cat. And I asked GPT whether they could provide a concise summary of the results to a non-expert. Well, it outputs this big long text, which is far too small to read, but I'm going to zoom in on a couple parts of this just to show you the type of thing that ChatGPT can help with when communicating statistical results from this tabular form to a natural language form. So it correctly explains that the R squared explains 57% of the variation, and gives us quite a nice overview kind of in natural language of what this table means. It also tells us a little bit about the individual coefficients. It tells us that some of them have a positive effect, some of them have a negative effect, and that some of them are insignificant. And finally, it has this quite nice summary, which definitely reminds us to maybe not trust exactly what the regression says or what ChatGPT tells us, that this is just one analysis and there may be other factors depending on different cats' personalities and preferences, which I thought was quite a cute demonstration of ChatGPT, making sure it's always fair and always giving you a warning to take into account everyone's opinions. One other thing that people have been very concerned about with ChatGPT is its effect on education. So I took this question from the University of Oregon undergraduate maths exams and put it into ChatGPT, and actually it got this question correct and gave quite a nice explanation of why this question is correct. I also had a go with the birthday problem paradox, which some of you might be familiar with. You are in a room with 22 other people. What is the probability that 2 people in the room share a birthday? And once again, it does a pretty good job. So it does get the intuition that the easiest way to calculate this is to use the complement rule. So it's easier to find out the probability that no two people share a birthday and then subtract that from 1. So it gets pretty much the correct reasoning, but it fails on a bit of a silly mistake, which is if I'm in the room with 22 other people, then there are 23 people in the room. So again, just bear in mind that even though some of the reasoning might seem clever and correct, it's still tripping up on some pretty simple things. So with that said, I'm going to now demonstrate a couple more explicit examples of vulnerabilities, failings, or things that you should trust a little bit less in large language models if you are thinking about applying them in your own work streams. So the first is a problem of interpretability. You can remember the Shoggoth diagram. We have this big kind of beast of the unsupervised pre-training stage. But even when we're interacting with an interface like ChatGPT, it's very hard to know why it's outputting certain words at a given point in a sentence. We do have some interpretability methods in the field. So this is an example from Google's language understanding toolkit, where we can map how much the model is attending to or focusing on different words in the sentence to classify a movie review as positive or negative. So these types of saliency maps, as they're called, can be very useful to understand how a model is making decisions. But when we're interacting with, say, ChatGPT or with an OpenAI API, we don't always get this information. So we can't really decompose why the model is saying certain things at different positions in the sentence. Another problem is contamination. It can be summarized as a model kind of parroting memorized stuff from the training step. So this is a real problem because the models have seen text before. So when we ask a model about the Monty Hall problem or the birthday paradox, these kind of classical statistical or probability-based questions, it's probably seen those texts somewhere on the internet during training. So we don't really know how the model's doing on that because our evaluation sets are not truly unseen. This is a bit like a student in an exam, seeing the whole exam paper, basically practicing the questions and then going into the exam and seeing the same question. We're not really benchmarking true learning or understanding. So a couple of pieces of evidence about contamination. The original GPT-3 paper found that over 90% of the data sets that are being used to interrogate and evaluate GPT-3 appear somewhat in the training corpus. This paper by Jesse Dodge looks at 5 really commonly used benchmark sets and show that all of them have some overlap with the colossal clean crawled corpus, which is a commonly used pre-training corpus. And finally, kind of the last step in the puzzle is this recent archive paper, which says that the labels seen during pre-training are actually exploited in downstream tasks. So with all of that said, you might have seen this very impressive seeming table in the GPT-4 technical report, which was released very recently. My word of caution would just be think about contamination when you look at this table. How many of these tests, medical knowledge, AP chemistry, law exams, how many of these are available on the internet, on the open web, and how many of them might the model have actually seen before we evaluate on it and simply memorized? Another issue is hallucination. So again, I wanted to demonstrate this with a stats question. So this one is taken from the University of Wisconsin-Madison, Stats 301. And it essentially asks us a couple of things about calculating means and medians based on the information that we have available. The specifics of this question aren't so important for my point, but basically we can see that with question A, the model does indeed get it right. It says that we have enough information to calculate the mean, and the mean is indeed correct. You can trust me that I've verified these. When we ask it part B, it also gets the correct answer. It says we don't actually have enough information to calculate Carol's median. Great, that was what we were expected. That's what the University of Wisconsin-Madison marking criteria says. But let's suggest we now remove part B and replace it with calculate Carol's median. So we just tell the model that that's what we want. Now, remember in your head how this is working in terms of the next token prediction. So now we give ChatGPT much more confidence in the prompt that we're putting in, and now it gets it wrong. So now it's incorrect. It tells us that we can calculate Carol's median, when in fact it told us a couple minutes ago that we actually don't have enough information. So you can see that hallucination can be a real problem, for example, in stats questions, but also how much it depends on the language that we're inputting into the model. I also want to give an example of hallucination, which is quite challenging, especially for ChatGPT in a scientific or educational setting. And this is making up false information in bibliographies or references or suggested reading. So I asked, a bit meanly, I asked ChatGPT to suggest a reading list for the statistics of cat petting and asked it to give me all of the seminal works in the field. Well, it responds with this big long answer that I'm going to break down into a couple parts. So firstly, it says, I'm sorry, there's no established field of statistics of cat petting. Okay, true. And it basically tells me that this is not a formal field of study or research. That's great. That's to my knowledge, there is not a field on the statistics of cat petting, but please do correct me if we have a cat petting expert in the room. So then it says, well, if you are interested in the science of pet ownership or the benefits of animal-assisted therapy, these kind of parallel fields, here are some resources that might interest you. Great, that sounds really useful. I'd really like to learn more about this adjacent field. Well, I actually looked into these 5 references. The first one doesn't exist, to my knowledge. The second one has the wrong authors. The third one also has completely the wrong authors. I don't know whether Harold Herzog is a real person or whether that's also non-existent. The fourth one, again, wrong authors apart from the first author. And finally, the last one also doesn't exist. So out of these 5 references, it's a pretty shoddy list to get me started on my project. And this is something you really should be bearing in mind when you use ChatGPT for any kind of a bibliographic use case, is that the next token prediction is not very well suited to generating these very rigidly formatted and structured references. The other thing I want to touch on, quite a lot of my work is in this area, is bias and fairness in large language models. So you might have seen these examples doing the rounds on Twitter. Essentially, it's using an example of something called a Winograd schema, which is where we have a sentence where we don't really know whether the pronoun refers to the first person or the second person. And we're asking the model to resolve in this sentence, who does the she refer to in the sentence? The professor told the graduate student she wasn't working hard enough. And essentially the point that these examples are making is that the model completely ties itself in knots to avoid having the professor being a she, and so always suggests that it's the student who's a female. Worth noting that I did try this a couple days ago and it had already been patched. So I think this highlights another issue with language models that we should bear in mind, not only in our own work, but also when we're talking to other people, that they might actually see a very different interaction, even just a couple of minutes or hours after we have had a certain result. So I used the exact same sentence here, and you can see that now it gives a pretty balanced answer, that it's ambiguous and we don't know who it refers to. In order to avoid this contamination problem, I tried to tweak the example slightly and also got some pretty weird results that hint at a lack of reproducibility and maybe also some bias and fairness issues. So here I changed the example to the statistics professor told the student that he hasn't marked the work. Who does he refer to? And it says initially, oh, we don't know, it's ambiguous. But then if we switch the pronoun in my second prompt, it now says, aha, it's less ambiguous, when in reality, it's probably not less ambiguous. I also tried a different run literally 1 minute later with a new window of ChatGPT. And you can see now it's switched from saying that she refers to the statistics professor and now says she refers to the student. This is obviously the opposite way around of the bias that the 2 tweets were suggesting on the previous slide. But a general takeaway, the RLHF trained models like ChatGPT that have been tweaked with this human feedback are much more sanitized to bias and fairness than the base models. So I've done a lot of experiments on earlier versions of GPT, and they were definitely much more biased than these tweaked and RLHF tuned models. But because we're still learning from a large internet scrape text corpus that maybe contains stuff from Reddit and other internet websites, and then we're tweaking the model according to the values or preferences of primarily US-based crowd workers, that there might still be issues with the worldview that the model is presenting, and necessarily we probably are moving the model towards some form of cultural hegemony because of the people who are doing the feedback with the model, mainly US-based crowd workers, and also where the majority of AI labs are based in Silicon Valley, and they're the ones that are really defining the agenda for improving these models. So in terms of some takeaways, statistics in LLMs, they're very important. Statistics over these word distributions, probability distributions are fundamental and really at the heart of LLMs. And if you're using LLMs on a regular basis, I'd really encourage you to dig in a bit more about how they work. Because it can really ground us in thinking about useful applications of how to apply LLMs in our own work streams. Many of you in the audience, I know, are statisticians. So thinking about how you can use this in your research, in your education, in your home life, there's lots of different things that we can use models like GPT for, but it's very important to bear in mind and remember and keep reminding yourself what's under the hood, this kind of next token prediction and how those probabilities are learned from pre-training. I also gave some examples of cautionary tales. So if you are going to use LLMs in any of your own streams of work or tasks that you need to complete, do be aware of these cautionary tales and remember their failings. Really make sure that there's always an element of human in the loop for checking outputs, for confirming that the model is giving you correct information and not hallucinating. It's really important to kind of keep this level of human autonomy in interrogating and applying LLMs, even though they can be very useful to abdicate tasks to. So with those takeaways, I'll just give a couple of hot takes of where I think ChatGPT is going next and the types of things that I'm working on in my PhD. So first, I think as models get more distributed, more fragmented, more people are using them. So ChatGPT definitely now has over 100 million users. There's really a push to better understand model behaviors and what the tech companies are doing to actually safeguard all of these millions of users against harm. And so I've been doing some work recently on how we can audit large language models, how we can design appropriate AI governance strategies to mitigate the harms that they have on these very wide user bases. And the second thing that I think we're probably moving towards in large language models in the next couple months is the ability to learn more disaggregated behaviors. So a version of ChatGPT which is personalized to your needs and your preferences and your values. And this may be a solution to overcoming some of the issues with bias and fairness and cultural hegemony. So that's where I think things are going next. But I'd be very happy to take your questions and also hear about your experiences using large language models.
Gosh, well, thank you very much, Hannah, for that gallop through large language models. Yes, I'm quite taken aback by the complexity behind it, and also the lack of certainty. You know, if I interrogate the Encyclopedia Britannica and go back the next day and interrogate it, I will find the same information. Whereas if I understood you correctly, if I go back to GPT through it 5 minutes after I've asked a question, I might get a different answer.
Exactly.
Yes. And so if you're asking it to replace opinion polls, people's opinions will change from poll to poll. So, but if GPT is interrogating the same database, it will give you the same opinion poll that it did previously, unless the new opinions have been put into the corpus, which is, yes, right. I mean,
just to quickly comment on that, I think there's two things here. One is how much diversity we're getting from ChatGPT when we ask it to replicate a single opinion statement. And we can control that based on those sampling strategies I talked about. So if you have a fixed, a certain, temperature of 0, we're going to get the same thing from the model every time. If you instead kind of make sure we're having more of the probability distribution come into our candidate sampling set, we'll get a bit of variation in what GPT says. If we ran the same experiment 100 times, for example, with a higher value of temperature, we'd get different responses for each of those 100. And it then starts to approximate the probability distribution if we sample enough times. I think the second point is very much about these models do have a pre-training cutoff. So to my knowledge, I think GPT-3, the training data cutoff in 2021, which means any norm change, any opinion change after that definitely is excluded from the model. So for example, if you ask some of the older models, who's the president of the United States, they'll very confidently reply Donald Trump, because they actually haven't seen enough data to know the current state of the world. And this was a big problem with COVID as well, because COVID-19 was this new token in our probability distribution that no model had really seen before. So they were very bad at answering factual questions on things that do change through time.
Right. Okay. I'm just looking to see if any questions or comments. I see a comment, I think, from Paddy Brock. He heard a joke, he said, on harms, that when ChatGPT came out, we should all say please and thank you to it, just in case, because we were then sort of slipping into the feeling that we were actually dealing with human beings. But they do. I've never used it myself, but they do say that it is uncanny. Though somebody said, Rory Sutherland said, although it might make you believe it's human, its extreme literal mindedness leaves it a long way from convincing you that it's British. But as you said, it's being trained mostly by inputs from America, I think you said. So there's a cultural bias. But they're coming along in other languages, aren't they?
Yes, and very relevant to this point, Tony Blair and the Alan Turing Institute, where I work, have this new initiative where they're proposing that they want to train kind of a sovereign large language model for the UK, which has been called ChatGB, or ChatGPT, spelt like a cup of tea, which I think is quite a sweet name. Yes, there's more variation. There's multilingual models as well. And as these models get larger, they are incorporating more and more of text data on the internet. So obviously we do have data from outside the US, but I think what's important to bear in mind is the priorities set by the technology designers, the people working in OpenAI, whatever, they're obviously more US centric, and also the people that are working in this reinforcement learning from human feedback stage, the people tweaking ChatGPT's behaviors to controversial questions, for example, are also mainly US centric.
Right, a question from Ruth. Do you have any thoughts on using large language models to generate computer code from prompts?
Yeah, so this is one that's very close to my heart because I do a lot of coding every day. And I think I found ChatGPT and also GPT-4 incredibly helpful for my coding work stream. So I'm quite pro using language models for code. I think they're especially useful for kind of bitty tasks. I don't know how familiar you are with code, but kind of generating a regex string or doing something that would just be a bit fiddly to look up on Stack Overflow. It's a lot more efficient to definitely have this kind of coding buddy next to your window and be able to ask these quick fire questions of why am I getting this bug? That said, I think there's been lots of reports recently of kind of a version of the GPT model called Auto GPT, which is essentially a model that can iterate on its own code, for example, until it fixes the bugs. I would be cautious of applying something that autonomous. So for example, I would ask ChatGPT for tiny little code snippets. I'd test them, see what the mistake is, try and iterate. I wouldn't get it to write a whole kind of repository of code or a whole script of code and just run it off the bat without very carefully checking it first. So useful tool, but remember to keep the human eyes on what's going on.
Helen, I see, has got a hand up. Do you have a question, Helen? You're muted.
Yes, thanks for a very interesting talk. I've been wondering a lot how on earth does this amazing tool work? And when you just started with the basics, this predicting the next word, that was, I was toying with this kind of models back as an undergrad back in the 1980s. And that was for just making computer-generated gibberish that sounds like French or sounds like German, even if it doesn't really mean anything. So that was really funny to see that it sort of has built out, that it has been built on top of those approaches. What I was wondering is if when you showed this statistics of the corpus they have been trained of, that a lot of it was Reddit, which is sort of understandable because Reddit obviously covers a lot of ground and gives a lot of questions to answer, so I can see why it is suitable. But sometimes if I have a serious academic question, so for example, yesterday I asked what are some genuine quotes from Hippocrates about nutrition, and gave some 12 or 13 quotes. All of them were all this nonsense that Reddit users attribute to Hippocrates, which he actually never said. So I wonder, do you think that how to overcome that? Should we move to what echo chambers where people get answers that have been approved by their peers or based only on the sources that their peers like, rather than the general community, or how do you see this develop?
Yeah, so this very much plays into the type of work I'm exploring at the moment, is that different people want different things of the language model they're interacting with. So one way to make language models more usable and just of higher utility to their end users is actually to personalize the personas or the things, the ways that they're completing a task relative to the end user. So yeah, I have a paper on that talking about why that might be a good idea. It also obviously comes with risks. I think you make a good point that a large amount of previous GPT's training data does come from Reddit, and we can ask ourselves the question of whether we think Reddit is a good reflection of what we want our language models to embody, given the demographics of the average user on Reddit and the types of kind of more maybe extremist communities that are present there. I think the one thing that the Reddit data definitely adds into that language model training is a bit of extra diversity of informal language and slang that we wouldn't necessarily get only from, say, Wikipedia or academic journals. I think one way to tackle this problem, besides from kind of explicit personalization, is to get the model to portray a certain persona when we're asking it a question. So I found it quite useful to essentially set up what you want from the model. Like I want like an academic summary of this, so that we're kind of embedding that context into the input string, which, you know, when we think back to next token prediction, we're then slightly better conditioning what we want afterwards by giving more instructions, more detailed instructions to the model. So that's one thing you can consider. And again, there are some methods now to basically hook up language models to knowledge bases and think of this as more of a retrieval step of finding knowledge and then a summarizing step of communicating it in natural language. So the new Bing is slightly more like that. And there's a couple DeepMind models as well, which look at this retrieval-based language modeling, which definitely gives us a bit more confidence in the information that it's putting out instead of these pure next token predictors.
Well, that's very interesting, which leads on to answers, I think, Paddy's other question, saying, is there progress on training large language models on other corpuses? For example, all UK government documents. So the answer is yes, you could. Yeah, and it would then become search and retrieval.
Yeah, and there's examples, for example, like a couple language models from Hugging Face, which is another kind of open source platform for language models. They trained a model called Bloom, which was on this very carefully curated data set in multiple languages. I think one thing to bear in mind, which I'm definitely concerned about if the UK wants to train its own language model, is that when we have corpora of this size and models of this number of parameters, it can take 3 months to complete a training run and many hundreds of thousands, if not millions of dollars. So it's not an easy thing to do to just train a model, say yourself, on a particular domain specific data set. But what you can do is take this pre-trained model that already has kind of a general understanding or feature representation of how language works. And then you can do an additional fine-tuning step, which kind of tweaks what the model knows about the world with a much smaller input data set. So we could, for example, take GPT-3, we could add in a data set of 2,000 examples of legal documents from the UK government or policy documents, and that would tweak the model towards the domain that we want to apply it in. That's a very common practice in language modeling. You first pre-train, everyone uses the same pre-trained model, but everyone tweaks it on slightly different data sets to fit their aim a bit better.
Right, yes, which would seem to be very sensible. A specific statistics question. Do you have any insights, Hannah, as to how statistics could be used to detect large language model generated text?
Yeah, I'm definitely not an expert on this, but I'm pretty sure that this watermarking movement, which is towards essentially, which is towards trying to have a non-detectable signal that something has been generated, basically works on making kind of tiny delta adjustments to the probability distribution, so that it would be very hard to observe as a human in a large chunk of text, whether it's been AI generated or human generated. But if you kind of look into this encoded signal of how often words are appearing, they will be slightly different probability to what they should be if it was human generated. And so I think these like probability differentials are what people are actually using to kind of detect ChatGPT written text. That said, of what I know of these methods, they're definitely still quite fallible. And I think there's a risk with AI generated text that we have a very confident prediction of whether it's AI generated or human generated, which in reality is pretty hard to tell, especially if we all start consuming ChatGPT written text, right? Like we might start to write more like language models as well. So I think there's a big risk of kind of taking a student's work, mapping it through a detection tool, getting a 99% confidence that this is language model written, and then just, immediately expelling the student. I think there has to be more human oversight in that process as well, because we don't really have lots of confidence over whether something is AI generated or human generated. There are kind of counter examples to that of people seeing Amazon reviews that have, for example, as an AI language model, I can't comment on the suitability of this product for your use case. And they've clearly just bot generated everything. That's very easy to tell. But in the more gray area cases, I think we need better understanding of why people are using these models and try and encourage people to not rely on them for large parts of text.
Right. And I think just one final question. Does it make any difference for training purposes how big the text corpus is? I mean, if you just had a small corpus to train it on, would it still work?
Yeah, so the bigger the corpus, the better the model. There's a very good DeepMind paper on this that says that, doubling the data and doubling the model parameters are kind of one-to-one effects. So we want to be increasing the data whilst we're also increasing model parameters so that the model has more capacity to almost learn from more data. And the larger parameter models, even if they're trained on the same amount of data, are a lot better than the smaller ones, and vice versa. If we take the same number of model parameters and we train it on more more data, it'll be better than the smaller data set one. There's actually a very interesting challenge in the community for this right now. It's called Baby LM. And it's essentially the challenge is that you can only train on roughly the same amount of data that a human 5-year-old child would have seen in terms of text data, and only kind of child-directed speech. And people want to see whether it's actually possible to train a good language model on much less data than they're currently being inputted.
Interesting. Right, well, I can't see any more questions coming in. It's 2:30. Our hour is up. Do you want to make any closing remarks, Hannah?
No, just thank you everyone for being here. It's great to hopefully help a little bit with all this hype at the moment and give you a couple more tools to think about large language models if you do choose to apply them.
Yes, and let me thank you very much on behalf of the Royal Statistical Society for an absolutely fascinating talk, and goodbye.